Hi all, this is Alan with Bothell STEM Coach, and today we're looking at the AP Calculus AB free response questions, number 6 from 2019. As usual, if I made any mistakes, I'll put corrections in the description below, as well as there's links to the PDF solutions in the descriptions. So functions f, g, and h are twice differentiable functions, with g of 2 is equal to h of 2 equals 4. The line y equals 4, 2/3 x minus 2 is tangent to both graph g at x equals 2 and the graph at h at x equals 2. Find h prime of 2. H prime of 2 is because this line is tangent to this graph. H prime of 2 has this is the slope of the tangent line, so this slope is 2/3. So let a be the function given by a of x equals 3x cubed h of x. Write an expression for a prime of x. That would be, I'm going to do product rule here. So this is going to be 9x squared h of x plus 3x cubed h prime of x. And so a prime of 2 is equal to 9 times 2 squared times h of 2 plus 3 times 2 cubed h prime of 2. So this is that answer for that. And then 9 times 4 is 36. H of 2 is times 4 plus 8, 24 h prime of 2, 24 times 2/3. And that's 144 plus 16, 160. Let the function h satisfies this is known that limit h of x can be evaluated using L'Hopital's rule. Okay. Use the limit as x approaches to h of x to find f of 2 and f prime of 2 and show your work leads your answers. Okay, so first of all, in order to use L'Hopital's rule, it has to be an indeterminate form. So when I approach x equals 2, it's got to be 0 over 0. Okay, so that tells me that 1 minus f of 2 cubed has to equal 0. Because the top is 0, so the bottom would have to be 0. Otherwise, I couldn't use L'Hopital's rule in order to use LH. So that means f of 2 has to equal 1. Because I bring it to the other side, f of 2 is definitely equal to 1. So that's the first part. F of 2 is equal to 1. Now we got to compute. Since it satisfies this, we have to say, well, what is L'Hopital's rule? I would take the derivative of the top over the derivative of the bottom. 1 minus 3 f of x squared f prime of x by chain rule. And because h of x is continuous, right? Because it's twice differentiable function, so it's continuous. It has to equal h of 2. H of 2 is 4, so this has to equal 4. So when I plug in 2, I get 4 over 1 minus f of 2 is 1. So that's 3 f prime of 2 has to equal 4. So that means this denominator has to equal 1, so f prime of 2 has to equal 0. To make that work. Right? I think that's right. Let me just double check that that's what I got the first time I did this. Yep, 0. Okay, so it is known that g of x is less than or equal to h of x for 1 between 3. Let k be a function satisfying that. Is k continuous as 2? Justifies the answer. Continuity means this. The limit as x approaches 2 of k of x has to equal k of 2. So I need to this is the definition of continuity. So what is k of 2? Well, k of 2 would have to be between h of 2 and g of 2. Right? Just given this inequality. And h of 2 and g of 2 are both 4. So 4 is less than or equal to k of 2, less than or equal to h of 2. So that means k of 2 has to be 4 in order to satisfy this inequality. Oops. So k of 2 is between 4 and 4, so k of 2 has to be equal to 4. So for this side, you use the same inequality, but you're doing the squeeze theorem. of h of x. So this one is also 4, and this is also 4, because they said it's continuous, right? So this part is 4, and this part is 4, and so this limit here also has to be 4. And so this limit equals that, so it is continuous. So yes, it is continuous. Okay, hope you found that helpful, and I will see you in the next video.